My name is Kelly Smith, and this is my Mammology final exam presentation. Starting with question 1, we'll discuss the two main suborders of Cetacea, which encompasses whales, dolphins, and porpoises. So Cetacea is divided into two main suborders, Mystaceti and Odontoceti. These two groups differ significantly in feeding methods, size, and other traits. Mystaceti are like baleen whales, while Odontoceti are toothed whales, and each group has its own set of unique characteristics that we'll go over. So the first major difference is in feeding. Mystaceti whales are filter feeders, meaning they use baleen pallets in their mouths to strain small prey like krill from the water. This group includes actually the largest species on Earth, which is the blue whale, and it can reach up to over 100 feet in length. In contrast, Odontoceti, or toothed whales, use their teeth to catch their prey, like fish or squid. An example of these creatures would be orcas and dolphins, and they are generally smaller in size compared to others. In this, these whales have a more varied diet and sophisticated hunting strategy than the Mystaceti. So, looking at one of the most fascinating species within the Odontoceti suborder is the narwhal. And narwhals are famous for their long spiral tusk, which actually is an elongated tooth that grows primarily in males, and it can reach up to 10 feet long. So narwhals are adapted to life in the Arctic, and they have a thick blubber to insulate them in icy waters. And their tusk or tooth is thought to be used for mating displays or social interactions, and though its exact function is still really debated, even as far as using it for communication and receiving signals or sending signals. So narwhals have a fascinating life history. They live in Arctic waters, migrate seasonally with the ice, and their calves are born in the summer, and after about 15 months of a gestation period, they'll stay close to their mothers for the first few years of life. So despite their incredible adaptations, narwhals still face significant conservation challenges. One of the biggest threats to their survival is climate change. As Arctic ice melts, their habitat is rapidly disappearing, and warmer waters affect their migration patterns and food sources. Additionally, narwhals are vulnerable to hunting, particularly by indigenous people in some areas, and disturbance from industrial activities such as oil and gas exploration. So, because of these threats, narwhals are currently listed as near threatened, and urgent action is needed to protect them and their habitat. Moving on to question 2, we're looking at the guest lecture by Vishnu, who shared some compelling insights on the challenges of coexisting with large mammals in India, a country with a very dense human population. The scale of human-wildlife conflict in India is just staggering. For instance, every year, tigers cause between 30 to 80 human deaths, elephants over 350, snakes resulting in 58,000 deaths annually is insane. And even in some regions, leopards are causing up to 24 attacks in a single year. So despite these high numbers, India is home to an incredible diversity of species, but sharing space with wildlife leads to unavoidable conflicts. A significant portion of the damage isn't just related to injuries or fatalities, but it's also crop loss and livestock predation, which directly impact farmers' livelihoods. Over 70% of conflicts reports involve crop damage and livestock losses, and this puts pressure um, on the farmers. Even though the government is compensating or is attempting to compensate, it's typically very minimal, like $47 for crop loss. And when it comes to the damage that wildlife is doing, this $47 just doesn't compare. And this isn't creating the incentive for farmers not to take actions into their own hands and eliminate the wildlife that is affecting their livelihoods, affecting their families. So, this raises the important question: can India balance wildlife conservation with minimizing these conflicts? How are innovative approaches being implemented to address these issues, such as early warning systems to track elephant movement and community driven initiatives to help farmers manage wildlife problems? It is an extremely complex challenge, but these solutions are a promising step towards balancing conservation with human safety. For question 3, I chose the ring-tailed lemur, Lemur cata. So this is a species that is native to Madagascar, and I am personally fascinated with Madagascar and love all the different creatures there, so I decided to choose a primate from Madagascar. So this primate is one of the most well-known lemur species and easily recognizable by its distinctive ring tail. And throughout these next couple slides, I'm going to cover the physical traits, feeding strategies, social structures, and a little bit more. Ring-tailed lemurs are medium-sized primates, known for their long, bushy ringtails. However, their tail is not only a distinctive feature, but it also helps them balance when leaping through trees. They have a large, expressive eyes that are well adapted for the dim light of Madagascar's forests and the tree coverage. They also have strong limbs, allowing them to really make remarkable leaps between limbs in trees. So they spend very minimal time on the ground due to these adaptations. Ring-tailed lemurs are omnivorous, with a varied diet that includes fruits, leaves, flowers, and even insects here and there. They are opportunistic feeders, which means they will adjust their diet based on food availability. They can forage on the ground for insects and roots, as well as in the trees for fruits and leaves. Their ability to adapt to different food sources helps them survive in Madagascar's diverse ecosystem. Ring-tailed lemurs live in troops that typically range from 6 to up to 30 individuals. Their social structure is matriarchal, meaning the dominant female leads the group. Females maintain strong social bonds with one another, while males often compete for status. Communication is key in their groups, with a lot of vocalizations, grooming, and scent marking used to maintain relationships and even signal distress. Ring-tailed lemurs are endemic to Madagascar, meaning they are found nowhere else in the world. Their range is primarily in the southwestern part of the island, where they inhabit dry forests, spiny forest, and scrublands. Madagascar's unique ecology has shaped their behavior and adaptations over millions of years, making them a true symbol of the island's biodiversity. Current research on ring-tailed lemurs is focused on their social behavior, including how they interact with their matriarchal groups and how their vocalizations are used for communication. Scientists have also studied their foraging behaviors, looking at how they adapt to food availability, which we've talked about. There is growing concern about the impact of habitat destruction, and researchers are working to understand how deforestation and climate change are affecting their populations currently. Ring-tailed lemurs are currently listed as vulnerable, um, with their populations declining due to habitat loss, illegal hunting, the effects of climate change, and even the illegal pet trade. Deforestation driven by agriculture and logging is particularly threatening their survival. However, there are conservation efforts underway, including the establishment of protected areas as well as ecotourism initiatives that help raise awareness and funds for their preservation. And here are my references. So let's discuss a growing conservation issue that is often overlooked: ocean noise pollution. While some people may think the ocean is silent to us, it's actually full of sounds that marine animals rely on for survival, whether it's to communicate, navigate, or find food. However, human-made noise is increasingly disturbing this natural soundscape, threatening marine mammals and other species. Throughout the next couple slides, we'll go over how noise affects different marine mammal groups and summarize key findings from recent research on this topic. So, ocean noise pollution primarily arises from human activities like shipping, even military sonar, oil exploration, and construction. So these activities introduce sound that can travel long distances underwater, impacting thousands of marine species. Unlike other environmental threats, noise pollution is invisible and often unnoticed, making it much harder to address and pull on those charismatic heartstrings of the community. But it's something that has consequences that can be devastating for marine life. Baleen whales, such as blue whales and humpback whales, rely heavily on sound for communication and navigation. Their low-frequency calls can travel across vast distances in the ocean. However, increased shipping traffic is disrupting these calls, making it harder for whales to communicate, especially over long distance. This leads to disorientation, difficulty finding mates, and even altering their migratory paths. For example, blue whales' calls have become less audible due to noise pollution, and this is affecting their ability to navigate and communicate during migration, which is key for survival. Toothed whales, including dolphins and beaked whales, use echolocation to navigate and hunt for food. So sonars and loud ship noises can also interfere with this echolocation abilities, making it harder for them to locate prey or communicate with each other as well. One tragic example is the mass stranding of beaked whales in 2002, and this was linked to naval sonar activity. The loud noises cause disorientation, leading to fatal strandings, and this, I feel like, truly highlights the severe impact human-made sounds can have on these species whose survival depends on precision sound detection. Sirenians, such as manatees, also rely on sound for communication and detecting predators. However, boat traffic, particularly motorboats, generate noise that can interfere with their ability to communicate or detect approaching threats. In coastal areas, motorboat noises have been known to disrupt manatee behaviors, making them more vulnerable to accidental collisions with boats. This not only poses a direct threat to their survival, but also affects their social structure and feeding behaviors. Pinnipeds, including seals, sea lions, and walruses, also use vocalizations to communicate and establish territories. However, Like the rest of them, loud noises such as those from shipping or oil exploration can cause stress and disrupt their breeding behaviors. An example is Arctic walruses have been displaced by increased shipping traffic, causing disturbances during really vital breeding periods. This noise pollution affects their ability to communicate with one another, and it can lead to decreased reproductive rates, further jeopardizing their population. While the impact of ocean noise on marine mammals is becoming increasingly clear, there's still much to learn. Researchers emphasize the need for more long term studies to understand how repeated exposure to noise affects different species over time. Additionally, noise reduction technologies are being developed to help mitigate the impact of human activities. I also believe it's important to note terms like the Lloyd's mirror effect, which refers to how sound waves bend over the ocean's surface and can mask important communication skills or signals. And the Lumbird effect, where animals increase their vocal volume in response to a loud noise, which can continue to lead to further disruption. And here are my references for question 4.